In my previous video, I have covered all the basics and some really cool theorems about triangles. Now, in this part 2 of the video, we'll continue with more powerful and interesting ideas related to the triangle. Let's get started. 17. Mid-segment theorem. It states that if you draw a line connecting the midpoints of two sides of a triangle, this line, called the mid-segment, has two special properties. First, it is parallel to the third side of the triangle. Second, its length is exactly half of the third side. This means the mid-segment creates a smaller, similar shape inside the triangle. For example, take a triangle with sides 6 centimeters, 8 centimeters, and 10 centimeters. If you find the midpoints of the sides measuring 6 and 8 centimeters and draw a line between them, this line will be the mid-segment. Since the third side of the triangle is 10 centimeters, the mid-segment will be 5 centimeters, which is exactly half of 10. 18. Circumcenter theorem. Take any triangle. Now draw a line from the midpoint of this side of the triangle such that it is perpendicular to this side. So we can call this line as perpendicular bisector of this side of the triangle. Now do the same for this side, and then this side off the triangle. All three lines will meet at a single point, which we call as the circumcenter of this triangle. This circumcenter is special because it is the center of a circle that passes through all three corners of the triangle. This circle, called the circumcircle, perfectly wraps around the triangle, touching each vertex. No matter the shape of the triangle, its circumcenter always exists, and it can be inside, outside, or on the triangle, depending on the type of triangle. 19. In-center theorem. The in-center theorem says that if you draw a line from each corner that splits the angle into two equal parts, these are called angle bisectors, they all meet at one point called the in-center. The in-center is the center of a special circle called the incircle, which fits perfectly inside the triangle and touches all three sides. 20th orthocenter of a triangle. Take one corner of the triangle. Draw a line from that corner down to the opposite side so it forms a right angle. This line is also called as the height or altitude of this triangle for this base. Now, do the same thing from the other two corners. The place where all three lines cross each other is called the orthocenter of this triangle. 21. Area of an equilateral triangle. For an equilateral triangle with side length s, the area is square root of 3 divided by 4 times s times s. This formula works only for equilateral triangles because of their perfect symmetry. 22. Heron's formula is a powerful way to find the area of any triangle using just its 3 side lengths. If A, B, and C are the sides of a triangle, then first you calculate the semi-perimeter S, which is A plus B plus C divided by 2. Then you plug it into the formula. Area is square root of S times S minus A times S minus B times S minus C. It works like a magic recipe for any triangle, no matter the shape. For example, take a triangle with sides 3, 4, and 5. First, find the semi-perimeter. 3 plus 4 plus 5 is 12. Divided by 2 gives 6. Now, apply the formula. Area is square root of 6 times 6 minus 3 times 6 minus 4 times 6 minus 5. This simplifies to square root of 6 times 3 times 2 times 1, which is square root of 36, giving an area of 6 square units. This method is especially useful when the height of the triangle is unknown. 23. The triangle proportionality theorem states that if a line parallel to one side of a triangle cuts through the other two sides, it divides them in the same ratio. This means the segments created on both sides will be proportional. For example, imagine a triangle where two sides measure 6 centimeters and 9 centimeters. A parallel line is drawn, cutting the 6 centimeter side into two segments, 2 centimeters and 4 centimeters. Since the line is parallel to the third side, it must cut the 9 centimeter side in the same ratio. This means the parallel line divides the 9 centimeter side into 3 centimeters and 6 centimeters, because 3 to 6 is also 1 to 2. 24. Basic trigonometric ratios in right triangles. In a right triangle, the 3 basic trigonometric ratios help relate the sides to an angle, usually called theta. Sine is the opposite side divided by the hypotenuse. Cosine is the adjacent side divided by the hypotenuse, and tangent is the opposite side divided by the adjacent side. For example, if a right triangle has legs of 3 centimeters and 4 centimeters and a hypotenuse of 5 centimeters, then the sine of the angle opposite the 3 centimeter side is 3 divided by 5. 25. The law of sines. If A, B, and C are sides of the triangle, then if A is the angle opposite to side A, B is the angle opposite to side B, and C is the angle opposite to side C, then sine law says that A divided by sine of angle A equal B divided by sine of angle B equals C divided by sine of angle C. Now, if this side length of the triangle is 8 units, and this angle is 30 degrees, and this angle is 45 degrees, then what will be the value of length of this side? Let me know your answer in the comments. 26. The law of cosine. It is like a more advanced version of the Pythagorean theorem that works even when the triangle is not a right triangle. It says that C times C equal A times A plus B times B minus 2 times A times B times cosine of C, where C is the angle opposite side C. If you want to learn more about this topic in detail, I've made a separate video on it. The link is in the description. First, finish watching this video, and then you can check that one out. 27. To find the area of a triangle using trigonometry, we can use the formula 1/2 times 2 sides times the sine of the angle between them. For example, if the sides are 3 centimeters and 4 centimeters, and the angle between them is 60 degrees, the area is 1/2 times 3 times 4 times sine 60. Since sine 60 is square root of 3 divided by 2, the expression becomes 1/2 times 3 times 4 times square root of 3 divided by 2, which comes out to about 5.2 square centimeters. This method is especially helpful when you know 2 sides and the angle between them, but not the height. 28. Apollonius's theorem. It says that if in any triangle of side length A, B, and C, the length of the median to side C is m, then if you take side A times A and side B times B and add them, the total equals 2 times the m times m plus 1/2 of side C times C. For example, if sides A and B are 5 and 5, and side C is 6, and the median to C is 4, then 5 times 5 plus 5 times 5 is 25 plus 25, which is 50. Now check the other side. 2 times 4 is 32, and half of 6 times 6 is half of 36, which is 18. So 32 plus 18 is also 50. 29. Circumradius formula helps us find the size of the big circle that goes around the triangle, called the circumcircle. The formula is A times B times C, divided by 4 times the area. So if the sides are 3, 4, and 5, and the area is 3 times 4 divided by 2 or 6, then the circumradius R is 3 times 4 times 5, divided by 4 times 6, which is 60 divided by 24, or 2.5. 30. In radius formula is for the small circle inside the triangle that touches all 3 sides. The size of that circle, called the inradius R, is the area divided by the semiperimeter. So, if the triangle has an area of 6 and a semiperimeter of 6, then the inradius is 6 divided by 6, which is 1. And that's it. I hope you found it simple and helpful. If you enjoy my videos and want to support my channel, consider becoming a Patreon, as it helps me create more awesome content for you. Link is in the description. Also, you can support my channel by joining our community and becoming a member. So,